Hello everyone. Today in this video we'll be discussing the third module super important questions of 18 DIP Mat 41. So before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. If you have any doubt, ping me on Instagram. And the topics are mainly two topics only. Like the first topic has three subcategories and the second topic has four subcategories. Okay, sorry, three subcategories. So for each of these you need to know the formula and basically apply it. Okay, so that's all I'll be discussing. How you will be identifying which is the type of the equation, what is the formula you need to apply. Easily you can get to know. The link is in the description box. There's a PDF. All these PDF whatever I am referring in these videos, that all can be found there. You can download and start practicing. There is no need to explain this module at all are super simple, but then still I'll be just explaining you what is the formula and what will be your approach for each question. Okay, so let's get started with the first question. So before that, let's have a look at the model question paper. In the model question paper also the same things will only be there, because whatever is there is it's in from the syllabus itself, right? So you'll be given with such questions and you need to identify which type of equation it is. Okay, so that's what we'll be discussing in this module. Okay, so let's open the notes here. So coming to the notes, I have to start from here, page number 58. So some basic informations are given here, but I'll be straightly jumping into the question and I'll be explaining you what you are supposed to do. So if you are given a question of this type, okay, if you are given a question of this type, what you have to do, it is d square by dx square, right? Write it as capital D square. Dy by dx, write it as capital D, and there is nothing here, so write it as nothing here. Okay, so d square minus 5d plus 6, this is a quadratic equation, right? So write it as m square minus 5m plus 6 and solve it. You'll get m minus 1 and m minus is equal to 0, m is equal to 1 or m is equal to 2. So those two are the roots which are real and distinct. Real means they are not irrational numbers, and they are distinct means they are different. Okay, so we consider the homogeneous equation. In this case we'll be solving it like this, and this is just the theory part which they have written. Okay, so different cases can arise. Either you get the roots here as 2 and 3, right? The case one is the roots are real and distinct. If the roots are real and distinct, what you are supposed to do is c1 is a coefficient, c2 is a coefficient, you have to write it as such. E1 raised to m1x and e raised to m1x, e raised to m2x, like that you have to write. M1 and m2 you got it, right? So that's what you have to substitute. So the final answer also will be looking like that only. Okay, so if it is the case 2, where the case 2 is roots are equal, that time you have to write c1 plus c2x into e power mx. M is the m1 is equal to m2 is equal to m. It's taken like that. Okay, if roots are complex means it's the irrational number which is root of minus 3. At that time what you are supposed to do is, suppose that you got it as a plus I plus 1 a plus or minus I beta, so you will be writing e power alpha x c1 cos beta x plus c2 sin beta x. Okay, so this is how you'll be representing it. This you will understand more when you'll solve the questions. So yeah, the questions already I explained you how you have to solve. That's all, and after that you will be writing the general solution. So in our question, what are the m values we got? 2 and 3, right? So how we will represent 2 and 3? This is real and distinct, so we fall in the case 1. In the case 1 we have to write c1 and c2 here, e power 2x plus e power 3x. That's all. C1 e power 2x and c2 e power 3x, that you will be writing with a addition sign in between. That's your final answer. Okay, then we have the next question. Here also we will be doing the same thing. Here cube is there, so we'll be writing d cube here. Solve it and find out the m1 m2 m3 values by calculator. After that you'll have to just write this equation and substitute the m1 m2 m3 values. The same goes for this ones as well. If it is real and equal, if it is equal here, at that time what we are supposed to do, c1 plus c2x e power minus 4x. Minus 4 is the two equal roots. And for the imaginary number, this also I'll explain what you're supposed to do. You got as m square plus w square is equal to 0, so m is equal to minus w square, m square is equal to minus w square, m is equal to plus or minus wi. If you represent this in the form of alpha plus I beta, at that time what you will get, beta is equal to w, and alpha is equal to 0. That's what we have written here. Alpha is equal to 0, beta is equal to w, and you'll be representing the equation in this form. What is the official equation? See that and compare what is the differences happening in both of these equations for real and for the imaginary numbers, which is case 3. Let me show you itself. That is the more better thing. So for the case 3, what we are getting is this one: e power alpha x c1 cos beta x plus c2 sin beta x. Okay, so alpha and beta you just have to substitute after you found out what is alpha and beta. After you substitute, you'll get this equation, simplifying which we will get this final equation. That's what you have to do in the first topic, which was the first topic about the different cases in the solving of homogeneous equation. The second half of the module deals with the inverse differential operator and the particular integral. Okay, so here 2 topics are there, and in that 3 subcategories are there. Okay, so what we found out is the normal integral. Okay, this is the normal integral general solution, and we'll have to find out the particular integral. Okay, so let's jump to the question and we'll understand from there. So before that, there are 3 types. One is the type 1, e power ax by fd. Second type is sin ax by ft, cos ax by ft, those types. And the third type is phi x. Phi x is nothing but a polynomial like x square plus 2ax plus b square, like that. Okay, so 3 types are there. For the 3 types also there are formulas. Solve as many as you can. It will give you more grasp in exam, and it will help you solve questions easily in exam. So my humble suggestion is that solve as many questions as you can. I'll just tell you the way you need to solve. Fine, then it depends on your practice. Okay. So the question is given as follows, and it is not equal to 0. Whenever it is not equal to 0, you have to do particular integral. Okay, that's why only this topic is there. In the previous questions, if you observe, there was equal to 0 here in whatever the question was present. See, if you observe carefully, in whatever the question is solved in the first half of the module, it was equal to 0, but here it is not equal to 0, it is equal to something else. Therefore we need to find out what particular integral. Okay, so the first part is same. You'll be doing the same thing here. Consider it as 0 and find out the answer. After you get the 2 and 3, write out its complementary function, which is the general solution. After that, find out the particular integral. It is of which form? The particular integral is from e power ax by fd. So you have to write e power ax, and fd is nothing but this equation. After you write that, what you are supposed to observe carefully: d is equal to 5. We have taken, why we have taken d is equal to 5? Because it is e power ax, right? You have to take f of a. See, this is f of d. Okay, so in d place, what we have to take? We have to take f of d, right? How we will get to know what is d? D is nothing but e power what it is raised to. It is raised to 5, right? So d value will take as 5, like that it is. Okay, so if we take as 5, we'll get the answer here. That's your final answer. For particular integral, just add with the previous answer, which is c1 e power 2x plus c2 e power 3x plus e power 5x plus 6. That's your total answer. In the same way, we'll be doing the remaining ones as well. That's about the type 1. In type 2, what we have cos 2x here. In this case, what we are supposed to observe carefully. In this case, after we have got this one cos 2x like this, we'll be simplifying these ones. Okay, like d cube plus d square minus d minus 1. It can be written as d plus 1 into d square minus 1. Here one formula is there. D value is nothing but 2. Okay, so d square can be written as minus 2 square. Okay, d square can be written as minus 2 square. Okay, so in the place of d square, I will substitute what? Minus 2 square. Fine. So if I write as minus 2 square, I'll get it as the equation as follows, and I'll be normalizing it. D plus 1 here will be, if it is there in the denominator, I'll multiply d minus 1 and d minus 1 in the numerator as well. D means differentiation. So observe carefully what will happen here. D square can be written as minus 2 square, it is minus 4, so minus 4 will substitute here. No worries about that. Here what will happen? D into cos 2x. D into cos 2x means differentiate cos 2x minus cos 2x. Okay, differentiate cos 2x minus cos 2x. What is differentiation of cos 2x? It is, I guess, minus 2 sin 2x, right? Yeah, minus 2 sin 2x minus just cos 2x will be writing here, minus cos 2x. Okay, so that's all. Minus 4 is here, minus 1, so it will be minus 5. Minus 5 into minus 5 into 5 is minus 25. So it will be written here, and the minus is taken here from here as well. So this is the simplified version. This is what we got is a particular integral. The common integral, we got it earlier itself. Just add them both. This is for the type 2, and the type 3 also works in the similar way. You can go through it. Just the polynomial equation will be there. And here one thing you have to observe is, like, you have to divide here. After you got this equation here, what will be 12x square, is it there, right? 12x square divided by, you'll be writing this in increasing order. 2, then 3d plus d square. Okay, so how you'll divide is start from 2 and 12x square. How much 2's are 12x square? Tell the table of 2 until you get 12x square. 2 1's are 2, 2 2's are 4, like that, keep on telling. 2 6's are 12 you will get, and 2x square is a x square. So 2 into 6x square is 2, which is 12x square, right? So write 6x square here. We'll get minus, and this will be 0 here. And since you have taken 6x square, multiply both of this by 6x square. So what will happen? 3d means what? 18. 3 6 are 18. D into x square. Differentiate x square. Differentiate x square means 2x. 2x into 18 is 36x, right? So let 36x here. Then d square into 6x. 36x again differentiate. That will be 36 only. And sorry, it's see, d square into 6x square. So it will be first 12x, right? 12x, and again differentiate, it will be just 12, right? So it will be just 12 here. And then what subtraction value you will get? Minus 36 minus 12, right? Minus 36x and 2. Stay the 2 table until you get minus 36x. 2 into minus 18x is minus 32x, right? Minus 36x. So that's same thing you will write here. Multiply both of this with this one, and right here if it is 0, don't write. Fine, whatever answer you get, subtract and keep on doing until you reach 0. What is the question you got? That's a particular integral, add it with the normal general solution. So make thorough with all of these concepts. Basically that's all what is there in this module. And hit the like button and subscribe to my channel if you want more videos like this. Your support helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.